So we are busy looking at oxalic acid. It is an organic acid, and we know that it is a weak acid. It comes naturally as a solid, so it is crystalline. And there are two waters for each molecule. There are two waters forming dipole-dipole forces with the oxalic acid. So this is called hydrated oxalic acid. And what is the hydrated oxalic acid's formula? So this is anhydrous oxalic acid. What would the hydrated oxalic acid's formula be? Like this, and a dot and 2H2O. It's the easiest acid to make a standard solution with. Why? What is a standard solution? Yes, standard solution. We want to make standard solutions. It's easy because it's easy to do what?
Another complication.
To weigh the crystals. Because it's a solid, it's easy to take a beaker, put it on a balance or a scale, and to determine exactly what the mass of the acid is. And the water of crystallization forms part of the molecule, so it will be part of the mass of the substance. So when you're going to calculate the moles of acid, you have to include the water of crystallization. So this question says, 6,675 grams of oxalic acid is dissolved in water to make a solution with a volume of 750 cubic centimeters. So this is the volume of the solution. That is the mass of the oxalic acid. We've answered the question, is it a strong acid, or and then explain your answer. It's a weak acid, and the reason why it's a weak acid, it hardly ionizes to form a very low concentration of oxalic acid, oxonium ions. When you have to, no, you can't say it is a weak acid because it's an organic acid. You have to stick to the definition's motivation. A definition's motivation is a weak acid hardly ionizes and forms a low concentration of oxonium ions in water.
Ask, how do you know? Let's say it's not oxalic acid. Let's say it's another acid. How would you know if it's a strong or weak acid?
You learn through experience. So you learn. The strong acids are hydrochloric acid, nitric acid, and sulfuric acid. You learn that. You get exposed to it, and you familiarize yourself with it.
So if it's not any of those, then it's a weak acid.
Phosphoric acid is of moderate strength. There is a list that I gave you to give you an indication of. Yeah. So you have to expose yourself to it.
And the thing is, the bases, that's the ones that I
Well, even all the group 1 hydroxides are strong bases. That's why the group 1 metals are called alkali metals. The group 2 metals are called alkali earth metals because their hydroxides and oxides are less basic.
Oh, okay, I get it now.
So your group 1 metal oxides and metal hydroxides are strong bases, and the group 2 ones are weaker. And the carbonates are also weaker bases. Okay, so to get the concentration of this solution, concentration is mass over molar mass times volume, 6.675. What is the molar mass of oxalic acid? It's
2 times
twice 12 plus 32 plus 1 plus twice 18. What is it?
126 times 0.75.
Okay. Have you done number C? So the new C is to calculate the pH of this 0.071 mole per cubic decimeter solution of oxalic acid. And to remember,
In every one,
it's a diprotic acid. Okay, so let's see if your concentration of COOH 2.2H2O is 0.071 mole per cubic decimeter. What is the concentration of the hydrogen ions?
it's 0.14.
So what did you do? Twice 0.071, which is
0.142.
mole per cubic
Just into
decimeter. What's your pH then? Negative the log of the concentration of the oxonium ion. So it is negative the log of 0.142. And you say it's a very small number.
0.85.
Your
Ma'am, what if you didn't do that top step, but you said 2 times 0.071 inside of that log thing? Would that be fine? Would you get the marks? Or would you have to show the working before?
Yeah, it's fine.
Why do you tell us what you mean?
Because it's diprotic.
So because it gives up 2 hydrogens.
Yeah. Negative
I'm asking a question. Why is it
is negative log of 0.142. 0.85. Okay, go for D. So in D you have to dilute this original solution, calculate the concentration of the new diluted solution. So you could follow one of two paths. You could follow the mole that you take out of the first solution by saying C1V1, and then the mole that you put into the second solution is equal to the mole that you took from the first solution, and that is C2V2. So you could either do two separate calculations and say it is 0.071 times 0,001. No, am I right? 0,01. 0,01, and that gives you 0, help me, 0.71 moles. This moles is going in here. 0.0071 equals concentration is what we're calculating, and this is 0,1. Okay, so C2 is 0.0071 divided by 0.1. That is, just check your decimals there, because 0.0. Okay, tell me what the scientific notation is then. Is,
for the first mole, you're missing a zero.
am I missing a 0? There. Okay, so this is 7.1 times 10 to the minus 4.
And then that one is still -3.
I'm missing a naught there, so that must go there, and this is 7.1 times 10 to the minus 3 mole per cubic decimeter. So we've done acid reacting with base. Next type of reaction is the acid reacting with a metal oxide. Now, a metal oxide is a basic oxide. So it's a basic oxide, and it will form a salt and water. Now here, your acid can react with any metal oxide. For example, let's choose an acid. Phosphoric acid. H3PO4
Calcium
and
oxide.
magnesium oxide will make magnesium phosphate. Sort out the formula for magnesium phosphate, please, and water.
That means the two is right like that.
No ways.
It's negative. 3 negative.
Oh,
So it's Mg2.
Okay.
I mean
Mg3
Caps on your
brackets PO4.
PO42. Then you need to balance the reaction equation.
3 and 2H. 3H.
2 phosphoric acids, 3 magnesium oxides. How many waters?
3. I think.
6, 3. Yeah.
It's 3 now.
Yeah.
But it's calculated.
Now, the acid can also react with a copper oxide, but the acid won't react with copper, and that question we are going to answer a little bit later for why it's not reacting with copper. So another example, let's take hydrochloric acid, and it will react with copper oxide to form.
We're not going to do anything with the...
No, I'm just showing you what the products are and teaching you how to balance reactions. We'll do stoichiometric calculations later.
Copper chloride and
Copper chloride, and what is the valency for the copper
CCl2,
here?
man.
Yes, it's 2. So it's copper chloride like that, and water.
Oh, so we're using the two-stop notation for the copper.
Yes, this should be copper 2 oxide, and this is copper 2 chloride. To balance the equation, 2 in front of the HCl. Okay, the third reaction, can I move? Can I roll?
No.
So the third reaction is the acid plus a carbonate. It will make a salt and carbon dioxide and
Water.
so some examples.
Sulfuric acid
Sulfuric acid,
and calcium hydroxide.
it's a carbonate, so you've got to have a carbonate. Mila? Calcium carbonate.
Yes.
Calcium carbonate. So the salt that will form is calcium sulfate and carbon dioxide and water. Okay, to balance the equation, it seems to be balanced.
Yes.
Okay, now because this is a gas that is released and it will most probably be released very fast, you find effervescence. That's that boiling up, the bubbling up effect.
Like when you put like ACC 200 or something like that.
Yes, when you put one of those fizzy tablets into water, it's the carbon dioxide that is released during the chemical reaction that causes the fizz. Okay, so effervescence or the fizz is caused there. Here we get the test for carbon dioxide. What is a positive test for carbon dioxide?
The flame test.
No, not the flame test, the chemical test. Clear lime water turns milky. Why is that? Because carbon dioxide is an acidic oxide, and when lime water is a solution of calcium hydroxide, and what forms when this acid reacts with this base? Calcium carbonate, which is insoluble. So it will make the milkiness. This milkiness is because of the insoluble calcium carbonate powder that forms in the chemical reaction. So clear lime water is the calcium hydroxide solution, and the milkiness is because of the solid calcium carbonate that forms. What is another product formed during this reaction? It is water. Can we balance the equations? We learned that metal oxides are basic oxides and non-metal oxides are acidic oxides. So, yeah. So here, your sulfuric acid is an acid and your calcium carbonate is a carbonate. So the reaction will make a salt, carbon dioxide and water. the carbon dioxide is an acidic oxide, so when you bubble it through hydroxide solution, it will be an acid-base reaction again, a proton transfer reaction. So what happens? Calcium carbonate and water forms. So this is the salt and water, because this is the base. Which part of calcium hydroxide is the base? The hydroxide part, in terms of who? Lowry Bronsted, yes.
Calcium.
So because this is a weak acid, the carbon dioxide is a weak acid, your carbonate ion is a strong conjugate base. Therefore, hydrolysis will take place. So write an equation for the hydrolysis with water. Let me see what you can do there. So it's the carbonate ion in the presence of water.
Hydrogen carbonate.
It will form HCO3 negative and OH negative.
Yes.
So what will the pH of the solution be?
The pH of the solution will be less than 7.
According to Arrhenius,
Great.
It'll be higher than the base.
it is basic. It's greater than 7 because of the hydroxide ions that are formed. Okay. I want us to test what will happen if something like nitric acid will react with bicarbonate of soda. What's the formula for bicarbonate of soda?
C2.
It's sodium, hydrogen, carbonate. So it's also a carbonate. Okay? So a solution of sodium hydrogen carbonate will make sodium nitrate and carbon dioxide and water.
Yes.
Is it balanced?
Yes.
Yes. Just wanted you to expose you to sodium, hydrogen, carbon.